Here's a story that's all too familiar. You're deep in flow state working on your new Rust project and you're finally ready to build it. You do cargo build and it takes a minute and a half for your project to compile. You tell yourself it's fine because it's the first build. The next one will be faster. It's not. Every small change requires 30 seconds to recompile. Your flow state is gone. Out of frustration, you scour the internet for some hope and find 3 key compiler optimizations. After applying them, the clean build and the rebuild come back almost 50% faster. In this video, we'll walk through these 3 optimizations, including tapping into experimental features that will make your Rust development workflow infinitely smoother. But first we need to understand exactly what cargo build is doing. Stage 1 is compiling. Rust reads your code, checks the types, and checks the borrows, all before it generates any machine code. Stage 2 is code generation. This is where we get real machine code written out into object files. The program doing that is called a code generator, and Rust uses one called LLVM. Stage 3 is linking. The linker takes every object file plus the libraries you use and stitches them into one executable to run. Now let's talk about the optimizations. The first optimization is the easiest, and it is a single line in Cargo.toml. By default, debug is set to true for a dev build. This is what happens when you run cargo build without any flags. It makes your dev build slow because it creates a map from the machine code back to your source code. This mapping allows you to use a debugger but comes at the cost of slower compile times. Often, we do not need the full debugging session for these quick rebuilds anyways. So we can update our debug setting to line tables only. Line tables only keeps only the file names and the line numbers. This debug setting will still show the line number that panicked, which is usually enough information for debugging. We run it, and this one optimization reduces compile times by about 9% on the clean build and about 21% on a rebuild. The best part is it's a very easy change to make. The second optimization speeds up the first stage of the build process, where Rust reads and type checks your code before any machine code is generated. For almost all of Rust's history, that stage ran on a single core. It did not matter if your laptop had 4 cores or 40. Checking your code happened on just one of them. So most of your machine sits there doing nothing while you wait. The second optimization fixes that. You put this in your cargo config file, and it tells the Rust compiler how many threads to use for type checking and borrow checking. I found that 8 threads was a good balance between speed and memory usage. When we combine our debug profile improvements with the parallel type checking, we get a 33% reduction in compile times, both on a clean build and on a rebuild. Notice that this optimization is only available on nightly Rust, so you need to add the nightly flag to your cargo build command. Your colleagues will thank you too, because this will speed up clean builds for your team's CI pipeline runs as well. Optimization 3 replaces the code generator from LLVM to Cranelift. Code generation was stage 2 of our 3 stages, which is where the compiler takes the internal representation of your code and turns it into machine code. LLVM is the default Rust ships with, but it also spends more time making your machine code fast. But an alternative is Cranelift, which optimizes less and produces the machine code faster. Again, we have to switch to nightly Rust and then add the Cranelift component. Next, we have to tell Cargo that we're changing the code generator. So here's our Cargo config file. The first thing we must do is turn on the ability to change the code generator by setting CodeGen backend to true. It's the unstable feature flag that allows us to change the code generator. The second one turns Cranelift on for dev builds only, so our release builds still use LLVM to stay fully optimized. When we add all 3 optimizations together, we get 46.9% faster compile times on a clean build and 46% faster on a rebuild. Note that Cranelift can hit code that it cannot compile yet, usually low-level CPU instructions. Since LLVM has been around for decades, and Cranelift is still new, LLVM can handle more code than Cranelift. So if you're using Cranelift and hit a compile time error, you may have to switch back to LLVM for that build. So try this one on a new Git branch, and if your project builds and you do not need a debugger, then it's free speed. So those are the 3 ways to speed up your builds. You can reduce debug information to line tables only if you do not need a debugger and get an instant speed up. Parallelization with Z-threads is nightly only. If you care about CI and clean build speeds, it can be extremely useful. Cranelift is also on nightly, and is on the edge of Rust development and can be another great speedup. Stack all three together and you get performance that can help reduce compile times close to 50%. And if you're interested in learning how to write production Rust, check out our Rust Live Accelerator. It's our tailored mentorship program where we help developers go beyond YouTube videos, build production-grade Rust software, and land their first Rust job. You can join the waitlist for our next cohort by heading over to letsgetrusty.com/join or by clicking the link in the pinned comment below. When you join the waitlist, we'll also send you our Rust developer roadmap as a small gift. So tap the link, join the waitlist, and I'll talk to you very soon.